All right, today we're in section 15.2. We're learning about the Pythagorean Theorem. Has anybody heard of the Pythagorean Theorem? Learned about it before? Okay, so it looks kind of fancy, doesn't it?
Yes.
Pythagorean, okay. And it's actually pretty easy to spell. I joke every year that you have to know how to spell it. It might be helpful to you. Maybe an extra point or two if you know how to spell it, Pythagorean. But why is it in this chapter? Out of all the chapters, why would I have a geometry section? Because in your notes, what do you see a bunch of?
Triangles.
See a bunch of triangles. So how does a triangle fit in with what we learned yesterday with square roots? Okay, and you're going to see by the time we get to the end of this lesson, you will see a very clear connection between what we did today and what we've done yesterday, and even what we're doing in section 15.3. Okay, so there's a couple important parts on your notes. If you have a highlighter or just star it or circle it, here are some important pieces of information to understand for the Pythagorean theorem. The first one. This is probably the most important. What kind of triangle does it work with? A right triangle. It must have a right angle. And the right angle is significant because my rule says, and this is the other part I want you to highlight or circle or star. The legs are the two sides that form the right angle. So you will see that those two sides come together to form the right angle. And those sides are labeled side A and side B. Those variables are very important because they will match into your formula. The legs form the right angle, and I label them A and B. The hypotenuse is side C, and it is opposite the right angle. The hypotenuse is labeled side C, and it is opposite the right angle. Okay? So that's really important so you can understand your formula. A squared plus B squared equals C squared. Well, if you don't understand that your legs are A and B, how in the world are you going to know what value to plug in? If you don't understand that the hypotenuse is C, how are you going to know what value to plug in for C? Okay, so you have to understand where on the triangle those sides are. Does that make sense?
Yes.
Okay, so that's what we're going to be doing today. A whole lot of solving for the unknown side length. All right, so in example 1, it says find the length, and it gives it away. Find the length of the what? Of the hypotenuse. Find the length of the hypotenuse. So I know that I'm solving for C. Okay? And I always, and guys, on your classwork, which let me just put in a plug on this, that is an optional assignment that will be counted as extra credit, but we are going to check that one. So if you don't like your grade, you can kind of have like a first right of refusal on your grade. But if you score really high, which is only like 6 or 7 problems, that could be a nice little boost to your homework average. Okay, so classwork for today is optional. All right, now you will have time at the end of class too to work on it. All right, so now here's the question. I know I'm solving for C, but how do I know what to plug in for A and B? How do I know if 5 is A or B? All right, well, here's the good news. It doesn't matter. As long as the two leg lengths are on the same side of the equation, it doesn't matter what order you add them in, right? Okay, so let's take a really simple example. What's 2 plus 3? 5. What's 3 plus 2? 5. Okay, so no matter what order you added in, you get the same answer, right? Okay. So I plugged in 12 for A. Why? Because 12 is like tall, A for altitude. Okay, and I'm just kind of like, symmetric like that, I guess. I don't know the word. Okay, B for base maybe. I don't know. Again, it doesn't matter. If you had said 5 squared plus 12 squared, you're still going to get the same answer. 12 squared is what? 12 squared?
144.
What's 5 squared?
25.
And then you add them together to get 169. But now, you got to get c by itself, and it's stuck with that exponent of a 2.
Oh, what you did in the 5.1.
Yes, you need to
Find square root.
find the square root, and there's the connection to 15.1. All right, to solve an equation that has an exponent, I have to take the square root of both sides. All right, but something is missing in my answer that I had in my answer yesterday. Do you guys remember what I told you? When you're solving an equation and you take the square root, what is supposed to be in your answer? The positive negative. So, before you start writing it, why is it not possible to have a positive and negative here in this scenario? Now, again, yesterday I solved equations, I put a positive negative. But in this scenario, my answer can only be positive. Why, Morgan? Because it's a measurement. And I can't have a negative measurement. Okay? Do you get that? All right, so any other time I'm solving an equation, it's positive negative, not when it's a measurement. How are we doing so far, guys? Doing okay? All right, so we're going to take a little bit of a breather, and we're going to do a classwork problem, okay? So what I want you to do is do this problem on your own and then compare it with your neighbors. See if you guys come up with the same answer. Okay, so on your classwork, you do not have to draw the original shapes, but I do want to see your formula. I want to see an equation. In this case, it would be 8 squared plus 15 squared equals c squared. When you add them together, it's 289, and the square root is 17. Again, it's not positive and negative because you cannot have a negative measurement. It's just positive. Okay, next example. Example 2, finding the length now of a leg. Okay, so now I'm finding a different side of the triangle. Now, instead of solving for C, I'm going to solve for A. All right, so now the question is, and please don't say it out loud yet. Which side, don't say it out loud, which side is my B? Which side is my B? No, don't say it out loud. Which side is my B? Gabe?
The right side.
Which is which value?
2.1 centimeters.
Okay. Can somebody confirm that and tell me why? Kyle? Yes, very good. All right, because he's saying it's not opposite the right angle. It actually what? It makes it, right? It forms the right angle. So I know that the two side lengths that form the right angle. I'm sorry. I'm so sorry. Okay, yes, the two side lengths that form the right angle are my legs. So 2.1 equals 2.9 squared. All right, so now evaluate your exponents and solve for A. So 2.1 squared is what? What's 2.1 squared?
I got 4.41.
4.41. And 2.9 squared? 8.41. Okay, and then what do I do to both sides? Yes, I need to subtract 4.41 to the other side. Okay, because my goal is to get A by itself. So now I have A squared equals, well, isn't that nice? 4. What's my last step?
2. Square root.
Square root it. A equals 2. All right, so it's really nice that all these examples work out to be even numbers, and then on your classwork, you're going to have decimals. Don't you love it how they do that? Okay, so here's the deal. Your instructions will say to round to the nearest tenth most of the time, and you can imagine, I mean, it's really hard to get side lengths that actually, when you square root it, it's an even number. So it'll just tell you to round to the nearest tenth, and that'll be our answer. All right, moving on to the next one. Now, okay, I mean, you could probably assume we solved for C, we solved for A, and now we're going to solve for B. Go ahead and do this one real quick. All right, which one is my A value? Which one is my A value? Someone raise your hand and tell me. Which one is A? 2 people? Come on, guys. Which one's A, Xavier? 16. Thank you. 16 squared plus B squared equals 34 squared. And remember, guys, there's a couple ways that you can identify that. 34 is opposite, so that's my C side. And 16 forms the right angle. Okay, so that's how you know. Sorry, that's like a little messy. You get what I'm saying. All right?
I got it right.
So 16 squared, 34 squared, subtract 256, and again, I've got an even square root, 30. 30. All right?
What is on the back of this page?
Anybody get?
Yeah, I just looked at. Oh my god.
Hey, okay, please, no.
Oh my goodness.
All right, stop. Any questions on this? Okay, let's move on. Okay, in example 3, we have a 3D figure. What kind of figure is that?
A pyramid.
It's a pyramid. But inside the pyramid, guys, look what's inside the pyramid.
Right.
How do you know it's a right triangle?
It has the little 90
Okay.
angle.
All right, so here's kind of a decoy. There's another 90-degree angle on the outside that really doesn't have any bearing on anything as far as what I'm solving for. What I'm looking at is I have a right triangle that is being formed by the height, the base, and then what we call the slant height. So 6.4 and 4.8 make up which sides? Which sides do they make up? Is it my A, my B, my C? What is it? It's my A and B. It's my legs. How do I know that? Because it
Makes the right angle.
makes the right angle. Okay, so even though this looks like kind of like an intimidating question, oh my goodness, like what kind of shape is this? It's just another way of showing a right triangle. Okay, so I'm going to use my A squared plus B squared equals C squared. 6.4 squared plus 4.8 squared equals C squared, which is my slant height. Okay, now I want you to solve for C. All right, 6.4 squared plus 4.8 squared. Ooh, that's nice. Works out to be a pretty even number, right? 64 equals 6 squared, square root it, and I get 8. Don't forget to label. Don't forget to label. All right, so you've got slant height here. All right, guys, last thing that we need to cover, okay? It is called the distance formula. It is not in your handout. I need you to hand write it in. And the distance formula is, sorry, let me get to that slide. The square root of x2 minus x1 squared plus y2 minus y1 squared. This should look sort of familiar to something else that you've learned. Okay? What does it look similar to?
Slope.
Yes, slope. Slope, right? Where you had 2 ordered pairs. And guess what? You're going to have 2 ordered pairs on this section also. And you're going to be asked to find the distance. And this is the distance formula. All right, so go ahead and write it down. You got it?
No.
Okay, so let's do a problem. Let's do one. All right, I'm going to give you 2 ordered pairs, and the sequence is the same as when you learned how to find slope. Okay, so your 2 ordered pairs are 1, -4, x1, y1, and 0, -1, x2, y2. All right, so here's the catch. All right, I just rewrote my formula. You have to be careful about your signs because the minus sign is already in the formula. What's going to happen if you minus a negative? Okay, so you are going to see some of that, especially in the distance problems. All right, so go ahead and try to find the distance between these 2 points. Okay, so help me plug in the numbers. Which one is x2? 0. Which one is x1? 1 squared plus, what's y2? -1 minus -4 squared, okay? I want you to simplify it even more. Do not put this into your calculator. What is 0 minus 1? -1. What's -1 minus -4?
3.
+3, okay? Now you can do this mental math. What is -1 squared? 1. What is 3 squared? 9. What's 1 plus 9?
10.
You cannot simplify this anymore because it is not a perfect square, nor does 10 have any perfect square factors, which this class doesn't talk a whole lot about simplifying radicals, but you will learn that in Algebra 1. Okay, if you understand that, we are good to go for 15.2.